what is something that bothers us here? What is that we do not want here? See this S square, or this is the variance is a square term. We are squaring the numbers. We are squaring the distance here. We are squaring the difference here. And what will be the unit here? Now, if we are talking about the speed data, then in that case, when we square the difference of the speed, the mean speed, and any data points in the data set, the unit that we will have here will be kilometers square per hour square. Or if it's the height, then the unit of this will be inches square, which is not very common. We do not commonly use or present our information in terms of the square of the units. Inches square, you will say the height of the students in this, the dispersion or the variance of the heights of the students in this class is 67 square, inches square, which is not a good representation. So what do? We take a square root of the variance, and that is called standard deviation. The square root of the variance is called standard deviation. So we compute the variance and then we take its square root, so that is called standard deviation. And as the name suggests here, deviation, how much deviation is in your data set. Deviation means like how much is it deviating from its mean. Is it deviating to the left or is it deviating to the right? So that is what we call standard deviation here. So going back to our SPS, let me share it with you. Okay. So then we come here again and to the descriptive statistics. Let's see. And we want to compute the variance. So we have variance here and the standard deviation here. And then continue. This SPSS software computes the standard deviation and the variance in our data set. So if the variance is 9.052 inches square and the standard deviation is the square root of it, which is 3. Is it clear? Is the concept of the variance is clear? Because it's very important. All other our following slides, especially finding out the sample size, is based on this concept. So is it clear to you? Okay, thank you. So this is the frequency distribution, or this is the histogram of the heights of the students of the data set, about the heights of the students that was collected for a class. So see here, it's kind of if I join all these data points, all the heights of these bars here, of these histograms here, I'm kind of getting a bell-shaped curve, but of course this is not an exact. We have a high point here, and then we have a dip here, and then a high point. So of course it is not an exact normal distribution, but that is how we plot the normal distributions. We find out the mean, we plot the histogram, and then we draw this curve around it, which tells us what type of, it's giving us a sense of the distribution of the data points, how the data points are distributed. Let's just discuss this normal distribution curve, and then we'll go to SPSS to do a normal curve, plot a normal curve. This is the normal distribution, a perfect normal distribution, or we say a symmetrical distribution. We see a symmetry here. Symmetry means like the proper distribution and equal distribution of the data set, with a single central peak at the mean of the data. So this is the mean of the data, this is the mean of the data, and we see a single peak here, and then see it's going down to the right, and it's going down to the left, and mean is the central point here. So 50% of the data points lie to the right of the mean, and 50% of the data points lie to the left of the mean. So this is a perfect normal distribution, and as one of the students earlier mentioned, that 68% of the if the distribution of our data set is perfectly if normal, or if our data set is normally distributed, then 68% of the data points lie within one variance of the mean. Okay, so this is the 68% of the data points are concentrated around the mean. Then the rest of these, which is like a 29% or 28% is here, and then it goes on and on. Now, when other thing is when the data is normally distributed, and when we plot this curve, then the area under the curve is 1, because see 50% or 0.5% of the data set is here, or 50% of the data set lies to the left and 50% lies to the right. So this is a perfect normal distribution or a curve of a data set. And here is more. So this is the mean, which lies right in the center, and it has a smooth peak here. See this peak, and then 68% of the data set lie within one standard deviation of the mean, and then about 95% of the data set lie within 2 standard deviation of the mean, and 99% of the data set lie within 3 standard deviation of the mean. So this is like 3 times 3 standard deviation of the mean. It's deviated 3 times from the mean. 68% is deviated 1 time from the mean, and this is the mean of the data set. So this, and again, it's called as a bell curve. This is all more commonly known as a bell curved shape, and you see here there's a bell curve shape here. So that is how we define the normal distribution of the data set. Is it clear now? Any question? Okay. So let's draw So again, we come here and we say descriptive statistics. This is the SPSS window. Under Analyze tab, do you have any question? Any one of you? Okay. And then we go to the frequencies. The height is already selected. We go to charts, and we tell it that we want a histogram, and then show normal curve on the histogram, and we'll see it will plot the distribution. You see here? So this is the histogram of the data set, of the height data set, and it draws this curve, normal curve, around the distribution, and we see that the data set that we have of the height, of course, it's not exactly 100% normal distribution. We see a peak here. We'll talk about these shapes later. These are some of the last slides, but we see these dispersion here. We see these peaks here. So this is a normal curve drawn around the data set that we have, and this is our actual data set. So using SPSS, you can draw the normal curve. First, you draw the histogram that gives you a sense of the distribution in your data set, and then you draw a normal curve around it to see whether it's normally distributed or not. Okay. I have these, some of these slides. Let me see here. That I kept. No, it is not that. It's not that it won't be acceptable, but we will say that it's not, the data is not exactly perfectly normally distributed, and it happens in all the data set. It depends how much dispersion do we have. There are some equations, there are some formula that computes that even in SPSS you will see that there are curves that we draw to find out whether our data is normally distributed or not. It's not in the natural phenomena, or in most of the experiments. See, we are not always able to collect the population data set. We always collect the sample data set. So it's not necessary that all the time, most of the time, the distribution of our data set is normal. No, it's not. It's not always possible, but that does not necessarily mean that it's not acceptable either. It is close to normal distribution. It could be close to normal distribution. However, if it is highly deviated from the normal distribution, then there comes the parametric and non-parametric parameters. Okay, so if it's a normal distribution, usually more than, if we have for any data sets or for any experiment, if we collect more than 30 data points, then the repetition, or the higher the number of the data points we have in our sample, more closely it will replicate the normal distribution. If we have only few points in our data set, then it is highly probable that it might not be normally distributed. So in that case, we go with the statistics that is related with the non-parametric distribution. Then it comes parametric and non-parametric. In our next class, when we'll do all these means and all the other parameters, we'll discuss the parametric and non-parametric data set. Okay? Okay. So here, I kept these slides for the last, but let's discuss it. Shape of the distributions. So you see here, when we draw the data sets, again, this is very related with the question. If we want to take more closer than 68%, well, if it's more closer than 68%, then it's again not normally distributed. So anything which deviates from 68%, because see, it's not, you don't want to concentrate everything around your mean. We say that for a distribution to be normal, for a data set to be normally distributed, 68% of the data points are one standard deviation from the mean, or are concentrated around the mean. If it's more than that, then again your data is not normally distributed. We want to see the it's not that we don't want to see a huge variation in our data set, but we want to see the variation in our data set. In nature, whatever phenomena we have, it's not that the same number appears every time, but the trend is very close. The phenomena is very close, is closely following normal distribution. So the normal distribution is that 68% of the data points lie around the mean. If it's more than that, then again it's not normally distributed. Okay? Okay. So see, these are the different shapes of the distribution. Now, shape of the distribution, and then which is called skewness. How skewed my data is. That tells me whether the data is normally distributed or not distributed. So we plot the shape. The shape of the distribution also tells us whether our data is symmetric or is skewed from its mean. So analysts, people who do statistical analysis, and definitely when you will do it for your dissertation, for your thesis, we are more concerned about the distribution of our data sets and how the data set is distributed between the extreme values. So there are three different types of distribution of the data set. Symmetrical is skewed towards the right, which is this, and is skewed towards the left, which is this. That is we call skewness of the data set. These are the parameters that we calculate to find out the shape of the distribution or the skewness in our data set. So in symmetrical distribution, you see here, this is a typical normal symmetrical distribution. In these type of distribution, the mean, mode, and median all are same. They all lie in the center. In this case, the data is skewed more towards right. The tail is more towards right. So for example, if we plotted the data set of about some medicine or about